Okay, hello everybody. My name's Helen. I'm a freelance software developer. I've been using Python since 1999, and this is my 4th year at PYCON UK, and also my first talk. So if I look or sound a bit nervous, that's why. I'm also, due to technical problems, I'm currently operating 2 laptops, so apologies if anything gets out of sync here. So I wanted to give a talk about mocking, not because I feel like I'm an expert on it, but because I've been kind of doing it for years, but also not always taking the time to do it well or understand what I'm doing. And I took on a nice new project earlier this year, and it had lots of interactions with third-party APIs, Oracle databases that I didn't own, lots of good cases for mocking, and I decided I wanted to learn more, and I think I've learned a few things, and I wanted to share some of them with you. So what is a mock? A mock is a fake object that can replace a real object. The main use of mocks is in unit testing. They're used as a way to control and isolate the environment that your test is running in. So why would you want this? Well, one reason is determinism, which means that the state of your tests should reflect the state of your code, and if your tests are failing, it should be because your code has gone wrong and not because of anything external to that. And it's really important that you can trust your tests. Things go downhill very quickly if you can't. It's really useful to be able to control the inputs of your test. Sometimes that's really easy. You pass in different parameters to your function. Sometimes it's not so easy. You've got inputs coming from remote calls and things embedded inside the function, and it's good to be able to simulate those things to see how your code responds to all situations. Speed is not always a reason in itself, but mocking happens in memory, so it's often faster than some of the things it replaces. And the speed of your test suite is really, really important. So I'm mostly going to be looking at unittest.mock, which is the lovely mocking library that comes with Python. It was written by Michael Ford, and it was a standalone library for a long time until we got to Python 3.3, and it was included in the main Python. It's still available as a rolling backport, so everything new that goes into that goes into the standalone library, so you can have it on Python, earlier versions of Python 2. There are 2 main things you'll find yourself doing when you use the mock library. You'll be creating mock objects directly and using patch to insert them indirectly. You can create a mock object by using the mock constructor with a capital M. You can give it the values you want it to have, and you can get them back out again. You can also, everything that you haven't set up is also a mock, so you can go down through layers of mocks and assign whatever you want. So I can go down into multiple layers of properties there. And mocks are also callable, so you can set your callable mock up with a return value, and when you call it, you'll get what you told it you wanted. So this is all part of setting up the right values that your code is going to pick up on when you run the code that you're testing, and you can go down as far as you want. Another nice way you can set up the environment for your code is side effects. Now, this can be an exception. So if you assign an exception to the side effect of your mock, when you call the mock, it will throw the exception. And that's useful for simulating failures. You can also give it a function. I don't find I use it that much, but you can make the outputs vary with the inputs. One thing I find particularly useful is that it can be a list. So you can set up return values to happen on multiple calls to your function, so you can make it return a different value each time. And that can also be an exception. So here I've set up a list of, oops. Oh, it's okay. Sorry, I've out of sync here. So here I've set up a list of side effects. So first call, it returns a value. Second call, it throws an exception. Third call, it returns another value. And then the fourth call, I've set nothing up there, so it raises stop iteration. So you need to make sure you've set up enough side effects. And you can also use infinite things like iterable, cycle, or count. So while your mocks are running and being used by your code, they're recording what's happening to them. And there is a family of functions, the assert functions, that you can use to see what happened afterwards. So we've got assert called with the checks which arguments it was called with, and it looks at the last call that was made. Got assert call once with that makes sure it was called only once with the given arguments. Assert any call, check that it was called at any time, or it doesn't care how many times, just that it was at least once. Then you've got assert has calls, you give it a list of expected calls, and you can choose whether it's specific about the order that they were done. It's worth keeping in mind that if you make a typo on one of these, if you misspell something or try to do something like assert called because you think that should exist, then it won't complain, at least up until Python 3.5 it now does. But yeah, that's something to keep in mind with using that. Python 3.5 also has an assert not called, which is quite useful. So that's how you use that. So I can just assert called with, it will look at the last call to that, and I can give it a list of calls to check it. So these calls are not always fussy about the number or the order of calls that were made, but they do care that you give them the right arguments, or at least that the arguments match. And you can customize that matching. Normally you do care exactly what was passed in, I think, but sometimes you might not. You might have a particularly complicated set of parameters and you want to give each one its own test. And you can use mock any to say, I don't care what this argument was. If you want even more control, you can use matcher objects. Now, these aren't actually specific to mock, it's just kind of a nice Python thing. And you can pass in anything that implements the equality operator. So say I wanted to check that a multiple of a given number was passed in. I've got a multiple matcher that I can set up with, say, 5, and so when I call my function, if I call my mock function with the value of 25, I can assert that it was called with a multiple of 5, and that passes. I can assert that it was called with a multiple of 4, and that throws an assertion, and I can give it a nice error message to make it clear what went wrong there. If you want lower level access to this information, there are several properties you can use to ask whether a function was called or how many times it was called, or just get right into the list of arguments that were given to all the calls. And that's nice if you want more control or more introspection. So, we've looked at a lot of the features of mock objects. Let's see how we actually use those in tests. Broadly speaking, we use what are called action assertion mechanics. So we create a mock, we get it into the right place, then we set up the inputs, the environment that the code is going to run in, then we run the code that we're testing, and then we check that our expectations of what happened are all met. So let's have a look at how we get that mock into place. Now, this is a simple case. You can create it directly and assign it to a method. Say you're testing an object and you want to mock another object on, another method on that object. You can just create a callable mock and give it a return value and just assign it. So yeah, I'm just testing greet function, checking it says happy birthday when it's the user's birthday. And because that depends on the current time, that's something that's quite nice to mock. But sometimes you need to mock something that you can't access directly. And that's when you need to use patch, which will give you access to that kind of thing. So you give patch a path to an object or a module or a class, any kind of normal sort of Python import lookup. It will create a mock object and it will ensure that that gets returned when Python looks up that path for as long as the patch is active. And in your test, it will give you access to that object. What it actually gives you is a magic mock, which is like a mock object, but it also mocks the magic methods in Python, but we don't tend to need to worry about that in most cases. So patch is really versatile, and you can use it in quite a few different ways. It can be a decorator or a context manager, or you can control it manually if you want more control there. So patch is a decorator. So this is a function that it takes a username, it looks up how many followers they've got, how many followers that person has on GitHub, and returns that number. It uses the GitHub 3 API client, which you just invoke, create the GitHub object, and sorry, I've got out of sync again. Okay, so here's the code, and yeah, you just create an API client and access the user and their followers property. And the thing we want to mock there is the GitHub client. That's kind of the edge of our system, and it's where somebody else's code, it's where our code ends and somebody else's begins, and it's also close to where the network conversations are happening, so we don't want that stuff really happening. This is the patch form of decorator, the decorator form of patch even. So automatically creates that mock and passes it in, it injects it into the lookup, and then we can do things to it. It can also be a class decorator, and it just, if you're using the mock, you want it in every function. You should take care with if you've got multiple patch decorators you want to apply, because they operate from the inside out, so that inner patch corresponds to the first mock parameter you'll have. It can also be a context manager. This, I think it's a little, I think the decorator form is prettier, but this gives you more control over the scope, and it's also good if you're using something like py.test, where decorators might interfere with other things. And you can manually control the object that comes back from patch. You can call start to get your mock, and then call stop when you're done with your mock. Make sure you do call stop, or it'll leak into other tests. Something I struggled with when I was trying to learn more about mock was how the lookups work and what path you need to give patch. In the example I've given, that's quite simple, because GitHub utils, when we import that, it imports GitHub 3. When we get to the patch, we're looking up github3.github. When we get inside the test function, we call getFollowers, and that does a lookup on github3.github. And that's the same thing we patched, so the mock works. But if we'd done it like this, if we do from github3 import GitHub and use that object directly, use that class directly in the function, when we import GitHub utils, it does that lookup. It goes down into the module and it gets the GitHub class. So inside the test, when we call getFollowers, that lookup's already been done. So the thing that we've patched is the thing that was already looked up before we patched. So we patched too late, or we imported too early, or trying to solve those things would be kind of not nice. So what we do is we patch the path that we actually imported. So patch github utils.github. So you have to address the object by the name. You have to address the object you want to mock by the same name under which it is looked up, and the Python docs say pretty much that. So when is it good to mock? Usually when it's inconvenient or impossible or otherwise maybe slow to generate, to make things happen with the real code. Simulated failure, you don't want to fill up your disk to see what happens, what your code does in that situation. You don't want to max out your API rate limits just to do that, at least not every time you run your unit tests. Same thing for getting the current time. You don't want to mess with the system clock. Randomness ought to be pinned down if you've got random things in your code. And then third-party APIs, even for success cases, it's really nice to have whatever inputs you want. So if you've got any enforced slowness in your code, like calls to time.sleep, I find that's really useful too. So here I've got an example of a delay loop. It iterates around and tries to call a function, and if an exception is thrown, it will delay for a second and then carry on and try again. It doubles the delay each time. We need mocking for a couple of reasons there. We want to be able to simulate the failures so we can test it correctly, and we want to stop that delay from actually happening because you don't want that every time around. So here we use a few of the things we've talked about. So we patch time.sleep, we get a mock object back. We're creating a mock function inside our test, and that's got a list of side effects. So we're going to tell it to fail the first 2 times and then succeed on the 3rd iteration. So then we can just call our retry loop with that and check the results. We check how many times our function was called. It should have been 3. And then we can check that the sleep calls happened without them actually having to happen and delay our code. Mocking the time is another one that can be a little bit tricky. Because the date module or bits of it are written in C, you can't dig down and mock their attributes. If you try to mock date.today, this is what happens. You get told off. You can't set those attributes because it's all internal. But you can mock the whole date module. So it can be a little less convenient, especially if you want to use other bits of that module for real, but I'm not sure I know a better way of doing that. Mock library also comes with a nice little helper to help you out with mocking the file system. It's called mock_open. And you can call that with the data you want your file to have. And then you have to patch open on the module that it's being called in, because then that will intercept the lookup there. And inside the context manager you get there, you can just call open and it will get the right data out. And that gives you useful file things like you can read lines. One thing you can't do is iterate over that file. It's not iterable. You can make it iterable, but you have to mess with it a little bit so that you can have nice Pythonic code like you want there. So we get hold of the mock with mock open, and then once we've got it, we can dig down. We have to go through the context manager as well, because we want to open with a context manager. And then we can set up the the iterable values that it's going to return when you iterate over it. I think I'm a little short on time, but I'm just going to show you mocking a read-only property, which can be a little bit harder because of the way properties work. You can't just assign a mock to your property. You can't just assign a value because you just can't set that attribute. It's read-only. So you can use patch object to do that. And you need to make sure you patch it on the class rather than the object you're using. And you give it this parameter called new callable, which tells it what type of mock to create, and it's a special type called property mock that lets you do this. And so then once you're inside there, you can treat it as a regular mock and do the things you wanted to do. Should you mock the other layers of your application? It's maybe a little bit more controversial, and not everybody likes doing this. It can be more pure and lead to better design if you do that, and the thing you're testing is just the thing you're testing and it's not touching any other code. It can be great for, it makes your failures more specific and can give you more realistic idea of your actual test coverage, and it's a bit faster. On the downside, it can be harder to read tests like that. It can be harder to write them. Sometimes they can seem a little bit meaningless. You can end up with functions that look just like, you can end up with tests that look just like the thing they're testing, but more mocky, and you wonder, what am I actually testing here? And they don't test the thing between layers. And if you haven't read the testing Go book, I really recommend you do. It's got a great illustration of all this. And yeah, that's it.